Okay, these are some additional practice problems with dimensional analysis, factor label method. We have a practice sheet where I'm going to do numbers 8, 18, and 20 with you. Just remember that we're on this sheet, we're converting from moles to grams, grams to atoms, grams to maybe molecules. Don't confuse the word mole with molecules. If you see the word molecules, that means you're going to use Avogadro's number, 6.02 times 10 to the 23rd. If you see the word mole, it's probably just going to refer to like 1 mole of something. So 1 mole is made up of 6.02 times 10 to the 23rd molecules. So molecules you can't see, a mole you can see. You can put it on a balance and weigh it out. All right, look at number 8, where it says how many atoms are in 2 moles of lithium. The word atoms indicates you're going to have to use Avogadro's number, okay? As always, we start by writing down the given. So it says 2 moles, 2.00 moles. So that's our given. So we're going to write down 2 moles first, all right, of lithium. Now, I want to get rid of lithium and go from moles into atoms. All right, that's where you have to say, okay, what do I know? What's some of my common conversions? All right, I know that I can go directly from 1 mole of lithium directly into atoms of lithium. Because I know that there's Avogadro's number of atoms in 1 mole of any element. All right, so this is where you're going to put 6.02 times 10 to the 23rd. Moles will cancel, and now all I have to do is multiply Avogadro's number by 2, and that would give me the answer. So these are simple little one-step conversion factor problems. All right, here's where you have to know how to use your calculator. All right, my calculator has a TI-30XA, and that's what you were encouraged to get in the syllabus at the beginning of the year, and I kept saying we're going to need these. So this calculator is easy to put in scientific notation numbers. I like to put those numbers in first and go ahead and just put 6.02, and this tells me it's exponential, so I'm going to say EE 23. I hit equals just to lock it in. You probably don't have to do that, but I would say just make sure it goes in there properly. So 6.02 EE 23 equals times 2, and I get 1.204. And here's how the calculator expresses it. All right, the calculator literally has it like this. That's not how we write it. So you don't want to write it that way. You actually write it 1.2. You can just carry it one place past the decimal. And that means times 10 to the 24th power. And we're dealing with atoms of lithium. Okay? So that's how you would do that particular problem. So again, going from moles, we can go directly into atoms because we know 1 mole of anything is Avogadro's number of atoms. All right, and just remember when you key that number in, 6.02, you're going to hit the EE button. All right, EE, and then the exponent is 23. So 6.02 EE 23. All right, and that's pretty straightforward. So that's how we do converting from moles into atoms. All right. If you look at number 18 on the paper, number 18 is going from atoms, and it says how much would it weigh. If it says how much would it weigh, it's asking you for grams. Okay. So you're going to put, again, the given first. So we write the problem down. So number 18 says if you have 1.6 times 10 to the 28 atoms of zinc, how much would it weigh? And just remember, if you're talking about weighing something, you'd weigh it on a balance, so your unit would be, you're going to grams. All right. As always, it starts out the same way. you're gonna write the number and the unit being given, okay? So 1.6 times 10 to the 28 atoms will be written first of zinc. All right, now, here's where you have to say, can I go directly from atoms of zinc into grams of zinc? All right. Yes, because I know that the total atomic mass of anything is still equal to Avogadro's number of atoms, all right? So if you look on the periodic table and find zinc, and we're going to round the mass up just so that we're able to easily work with it, it's 65 grams, okay? So the atomic mass of zinc is 65 grams, that's from the periodic table. And then the word atoms automatically means Avogadro's number, 6.02 times 10 to the 23rd. All right, sometimes students will get it all set up correctly, and then they'll get the wrong answer, all right? Let me show you the best way to put it in your calculator. Rewrite this whole top portion. So I would write 1.6 times 10 to the 28 times 65 divided by 6.02 times 10 to the 23rd. I keep that in parentheses. Okay? Now, I'm going to talk you through it, and this is literally how you're going to key it in your calculator. All right, I'm going to do 1.6 EE28, all right, times 65, and you have to hit equals. So that's going to give me an overall product in my numerator, okay? Divided by, now you need to open and close your parentheses just so your calculator doesn't do some weird order of operations thing. So I would do divided by, open parentheses, 6.02 EE23, close parentheses, equals. All right, now it's giving me a huge number, which is okay because it's, it's going to be big. If you're going from numbers of atoms to a weight, that's a lot of atoms. All right, and I'm going to go back through and double check my math, but I'm getting 1727574 decimal 751, which I can just round it to 8. All right, so when we round or when we get the answer should be expressed in grams. Okay, so let me do it one more time, make sure there's no error. So 1.6 EE28, I'm gonna hit equals just to lock it in, times 65 equals, divided by, open parentheses, 6.02 EE23, close parentheses, equals. Yep, and I get the same large number. And I'll have to write it right here because I'm running out of space here. All right, so my answer is 1727574.8 grams of zinc. Okay. So the big thing is just make sure that when you key it in your calculator that you know how to key it in. Just remember that the times 10 to a power is always EE and then that exponent. So you would literally say 1.6 EE28 and here 6.02 EE23. Okay. All right, and then the last sample problem is number 20, when we're saying how many molecules are there in 0.83 moles of hydrochloric acid. The word molecules or atoms automatically should tell you, oh, I got to use Avogadro's number. So if you see the word molecules or atoms, you're going to use Avogadro's number, okay? All right, so number 20, all right, looks like this. It says, convert, or how many, so number 20, how many molecules, just remember that should signal Avogadro's number, are in 0.83 moles of hydrochloric acid, HCl. All right. The only reason we use the word molecules instead of atoms is that HCl involves more than one element. So if it were just Cl or just hydrogen, then it would be atoms, okay? But since you're dealing with a compound, we use the word molecules. All right, same old, same old. We're gonna start with what's given. So I'm gonna say 0.83 moles of HCl times, if moles is in the numerator here, I want mole to be down here, all right? And I'm trying to get to molecules. So you gotta say, okay, what equivalency do I know is a true statement? Well, I know that there are 6.02 times 10 to the 23rd molecules in 1 mole of anything. All right, so I'd say Avogadro's number here, all right? Cancel moles, and you're left with molecules, all right? So you're gonna go I would go ahead and add, key in the Avogadro's number first, all right? So I'm gonna say 6.02 EE 23 equals times 0.83 equals, all right? And it's all over the number 1, so I have to divide it by anything. So the answer, your calculator is going to say 4.9966 to the 23rd. That's not how you write it, okay? You can let you round it. So basically that's going to round up to, it's so close to 5, you can just say 5. So 5 times 10 to the 23rd molecules of HCl, all right? So that's how you would convert moles into molecules. So you're going to use Avogadro's number if it says molecules or atoms. And those are additional practice problems for dimensional analysis.